just want to discuss and talk about one of the golden parts in Kubernetes on EKS and how we can securely connect pods or connect workloads that is running within EKS. Like, for example, that is actually running within EKS, and to see how we can connect that to AWS services. Because, of course, EKS is hosted on AWS, on AWS. So what happens if you want to connect those workloads that are running as pods or those services that are running within pods? How do you now securely connect them to AWS, right? And that's one of the golden parts that I want to discuss. So let's start with a very classic, a very classic request, right? And the request is very simple. So imagine you're a platform engineer, right? Or you're a DevOps engineer, or you're the cloud guy, that everybody runs to when there's an issue, right? So, and let's assume that there's a developer that comes to you to say that my applications are running in Kubernetes EKS, or my applications are actually running within EKS, and those applications, they need to read files to S3 buckets. So this is the engineer on the left hand side. So this is the engineer on the left hand side. Let me just activate my pen. So this is the engineer on the left hand side here, right? And it comes to the DevOps guy to ask that, you want his applications running within EKS to have access to S3. And it could be any service. It could be KMS, it could be DynamoDB, it could be any service. So, but the question now is that you want the applications or his workloads running within EKS to have access to AWS services, right? So how will you do that? Like, what is the first thing that would come to your mind? Right? What's the first thing that will come to your mind? And I'm sure that majority of us will be quick enough to, go ahead to configure AWS access key and secret access key. That's like the default of what everybody will do. I've also been guilty of this. So this is not to shame anybody, right? So I've done this as well in the time past. But what if I tell you that this is actually a very wrong practice, right? What if I tell you that this is a very wrong practice? Because what we tend to see is that many people, even till today, what they just do is that they just go to the AWS console to grab access key and copy secret access key, and then they will configure it either as a config map, or they would go ahead to configure it as a secret within Kubernetes. So again, things will work. The applications within Kubernetes will be able to communicate with AWS services. Things will work, but um, things will now get very, very, very messy, when the pod itself becomes compromised, right? So the question that you need to start asking yourself is that if I configure the AWS credentials, if I configure it manually as a config map or as a secret, the question that you should ask yourself is, what happens if the pod is compromised? Right? What happens if those credentials are accidentally committed to GitHub? I mean, like that would be a very serious breach, so to say. Or another question that could come to your mind is, how do you now rotate the secret? Let's say you have configured this particular credential. You have actually configured it across 200 200 applications. If you now want to rotate this, how do you now do that? Like, how do you now rotate the secrets? And of course, you would not want to do this, because if you go ahead to configure the access key and the secret access key, right, as an environmental variable, or you configure it as a secret, or you configure it as a config map, then you're going to be faced with all of these risks that is here. Credentials can be leaked, it can be exposed. It can be very difficult for you to be able to rotate those credentials. If the pod gets compromised, attackers will definitely get permanent access, as well as other risks, so to say. So the question now is that, is there a way to be able to avoid this, right? And the simple answer is yes. So if you are running your workloads on EKS, right, AWS introduced what we call IRSA, right? they introduced IRSA, and what IRSA stands for is IAM roles for service accounts. So what that means is that AWS is simply telling you that once you have pods running within Kubernetes, the first thing that you need to do is to, connect your identity, connect it to our own identity. That's just like the simple logic. So you're running within Kubernetes. Let me just move this up a bit. So I want so you're running your pods. So let's say we have workloads in EKS. Let me just change this to pencil. So let's say we have workloads that is running within EKS over here, right? So that this is your EKS cluster. We have pods. Let's say this is pod one, pod two, and pod three, right? Now within the pod itself, you need a form of identity. So a pod is running. How do you now identify that pod if that pod wants to communicate outside, the EKS cluster? You do that by configuring what we call the service account. So a service account is configured within the pod so that if the pod needs to communicate to an external service, let's say on AWS now, maybe S3 bucket or KMS now, for example, now what is going to happen is that when the pod wants to communicate with this um external workloads, right? Um, the pod itself needs to prove its own identity. And the way it does that is by making use of the service account. So that when this pod is going to AWS, AWS is going to see this pod, right, from the view of the service account. So the service account is the identity, right, that represents the pod itself. So whenever a pod is going out, you are not seeing the pod itself as an entity. What you are seeing is the service account, that represents who that pod is. It's as simple as that. Now, what is AWS now saying? AWS is now saying that now, I don't want you to hard code your credentials within the pod. What is going to happen is that send your identity to AWS. And once that identity gets to AWS, that identity is going to assume a role, right? And once that identity has assumed a role, the identity can now go ahead um make use of, maybe if it wants to fetch like an object within an S3, or if you want to do KMS and all. So that's just like the simple logic. So it's simple. So whenever you hear IRSA, right, you should know that we're talking about connectivity of what service accounts that is running within Kubernetes, connectivity of service accounts to what IAM role. That's all. So when the pod wants to communicate with AWS, the service account assumes a role, and then based on the permission that you have actually configured within that role, the service account, will be able to work based on that permission. So it's as simple as that. So sometimes it can be quite difficult to set up, right? And that's why AWS introduced another concept called pod identity. So that is much more simpler. That is much more straightforward if you want workloads that are running within your if you want to workloads that are actually running within your Kubernetes cluster to access resources on AWS, right? So, yeah. And that being said, um, again, don't get it confused. When you're talking about IRSA, you're talking about two identities. The first one is the service account, which proves the identity of the pod. So don't forget that. While the second one is the role, which is also an identity on AWS. But that role has specific permission of what can be done and what cannot be done. So that anybody that is authorized can now assume that role and then get short-term credentials. So it's as simple as that. Okay. So let's go down a bit and just talk more about IRSA, which is the IAM rules for service account. So you can think of IRSA as giving every employee in a company or in your organization their own access badge. So instead of everybody having one access badge, right, which is quite risky. So it means that your HR manager or someone that is working in another department can even have access to your server room. So by default, that's what it is. So, but instead of doing that, you want to um you want to ensure that everybody, that is working in that organization, they have their own unique access badge. So you can see this image on the left-hand side, right? So where um pod A, this is pod A here. So you can see pod A. So let me just switch to pencil. So where pod A here, pod B, and pod C, they all have one big key. So this is the key here. They all have one big key that opens all the doors to AWS. So pod A, pod B, and pod C, they all have access to S3, they all have access to DynamoDB, SQS, like name EC2 instances, like name all of the services that you have on AWS. So by default, if you don't configure IRSA, this is the risks that you face. And of course, we're going to like do a very quick demo of to prove that by default, your pod that is running within EKS, by default, they can assume the role that has been configured for that node. And we all know that nodes within Kubernetes services are where all our all of our workloads where they run. So by default, if you don't configure your RISA, right, any pod that is running on that node, by default, they can assume the role that has been configured for the node. And because of that, they can have access to whatever it is that role have access to. So this is a very big risk. And that is why we are talking about the golden patterns today. So this is something that you should avoid. So we're going to prove this shortly. We're going to run the demo, and then we're going to see that if you don't configure IRSA, or if you don't configure like a service account, the pod automatically gets access to whatever it is the underlying node has access to, which is quite risky, which is very, very dangerous. Okay, so we don't want to do this, but instead we want to ensure that each pod, right, they have, you know, um, they have restricted access to doing things within AWS. So for example, pod A here should only have access to S3. Pod B should only have access to what DynamoDB, and port C should only have access to SQS, rather than giving all of the ports the same access that the node has as well. So this is wrong. Why this is the best practice? Okay, so yeah, so let us go ahead and just showcase the demo, because of course this is like a show and tell, and we just have to showcase what we've done, the golden parts in Kubernetes, and how to avoid all of the pitfalls that we see all around. So let me just bring up my Visual Studio Code, and what we have right here is, and of course I'm going to share this repo so that whenever you are less busy, you can also just walk through the repo to see what it does. Right. So we'll start with an AKS cluster. Because of the time it takes to create an AKS cluster, I think it takes roughly between 10 to 20 minutes. So I've gone ahead to create an AKS cluster. And of course, you can also create an AKS cluster using different varieties, like using different methods. If you are the ClickUps guy, if you're just starting up, with cloud or with um, AWS, you can just go to the AWS console and create an AKS cluster. It's as easy as that, right? So, but if you don't want to use ClickUps, if you want to use the CLI mode, you can make use of the EKS control. With that, with just a single line, you can be able to create an AKS cluster, and then finally you can make use of Terraform, which actually made use here. And you can make use of any method at all. There are varieties and there are different methods that you can make use of to create an EKS cluster. So I've gone ahead to create an EKS cluster. And if you should go through the code, what's it called now? That's the TF files that I have here, which are just basic Terraform files. You can see in here there's a file called eks.tf, and in here I've already defined, you know, of course, it is not a Terraform class, but it is good as engineers for us to know at least fundamentals of Terraform, because we are now in the era of AI where you want to ensure that things are done, you are able to build things and then you are able to maintain things. And part of the tools that helps us to be able to do that is Terraform. So even if you are not a pro in Terraform, you should be able to just create like a simple Terraform script, that does basic functions. For example, that creates an AKS cluster. That's it. So if you just want to learn more about how to be able to create an AKS cluster um, from scratch, you might not want to go this route because you would first need to understand how to create an AKS cluster manually, right? And then you can now go ahead to automate it. Again, the general rule of thumb is don't automate what you have not done manually. So if you have created something manually before, you will know how that thing works. Like you will know how it connects from stage A to stage Z or to stage K or to stage whatever stage. You will know how that thing works manually. And then then based on that, if you want to, reduce your lead time, then you can now go ahead to automate. All right. So that's just like the simple TF script that I have here for the EKS cluster. Then I also have a couple of accompanying files. I have a file that also goes ahead to create IAM Roles itself. That also creates an S3 bucket and a whole lot of other information. So I don't want to bug you with all of the nitty-gritties of what it takes to create an EKS cluster. But once you have this repo handy, I'm going to share the URL on the Discord community page. Once you have this URL handy, and you also have the Terraform CLI installed on your Linux environment or on your Mac environment or wherever it is that you run Terraform, what you just need to do is just to run um, the Terraform plan, right? And then you do your Terraform apply. Okay, or first, if you want to initiate everything, Terraform init, Terraform plan, and then Terraform apply. That is for those that have, for those that use Terraform a lot. So once you do that, this is going to create an AKS cluster, and I have my AKS cluster here already. So I'll just go to the AWS console and type AKS. So this is going to take me to so this will take me to the EKS cluster. So you can see this was created about 10 hours ago. And yeah, this is the Champions League final. And at the end of the day, we already know who's going to win the Champions League final. I mean, we know ourselves. I'm not an Arsenal fan, but maybe PSG may win. All right. So yeah, so this is the Champions League final cluster, and within that, we just have basic information. We have overview, just a bunch of informations that we have here, resources, compute. So right now we don't have any resources because we've not deployed any workload within the cluster itself, and then we have compute, and then within the compute there's a node group, and the node group is what helps us to provision the underlying node, which in this case is just an EC2 instance, as well as other information. All right, so that's the first step you need to do. You must have a functional EKS cluster, which we have here already, which has been created. Then the next bit, I think I have an MD file. I have like a markdown file here already that just talks about all of the steps. So the first thing you have to do is to create your cluster, which has been done. We have also created networking VPC. We have also done the node configuration, which I just showed you, which is like the node group, right, attached to the EKS cluster. Then the next and the most important thing right now is we need to now define the role itself. So I've gone ahead to create a role here, and the role is called IRSA S3 reader role. So by the time you run your Terraform apply, that is going to create everything for you automatically. So let us go and verify the role, because again, remember, our our aim is to connect the identity that is within the pod, which in this case is a service account. We want to connect that identity to AWS identity, which in this case is a role. So the first thing you have to do is to create the role, which which I want to show right now. So on your AWS console, you can just click on AWS roles here and then paste in the role that has been created. Oops, sorry. Pasting the role that have been created here. So this is the role, and this role is like at the core of what we're going to be doing. So remember, the identity that is coming from Kubernetes is going to be communicating with this role. So the role is what IRSA S3 reader role, and the most important thing that you need to ensure is what we call the trust relationship, right? The trust, or you might also want to call it the trust policy. And what this does is that it it's just simple. It makes use of two things which you must always know. The first thing is what we call the OIDC, and I'm going to explain what OIDC does shortly, right? And then the next thing is you have to define the service account within the Kubernetes cluster itself. You have to define that in this trusted identity. So which is on line 13. If I maximize this a bit, which is on line 13 here. So what you are saying is that I want a service account, and this is very important. So if you miss this part, you will not be able to properly connect your workloads running within EKS. Sorry, your workloads running, yeah, within EKS, which is the Kubernetes cluster. You'll not be able to connect them to the resources within AWS. So what you need to do is within line 13, you need to define the service accounts, right? And how you do that is by, um, passing this particular value here. So you don't need to cram anything. You have to define system service account. The namespace here, we are making use of the default namespace. That is why we have default here. And then the name of the service account itself, which is the S3 reader SA. It's as simple as that. So again, define your service account here. And that is the service account that you have created on your cluster. Define it here and then make use of the OIDC. So question now is, how do I create the OIDC? But before that, whenever you hear OIDC, just know that this is the OpenID Connect and is just a protocol that serves as a bridge, between your Kubernetes cluster and your AWS IAM. That's all. So again, whenever you hear the word open OpenID Connect, just know that this is always a bridge, right? So it's a bridge. OIDC, it stands for Open ID Connect. And this is just a bridge. Just see it as a bridge, Um, it's a trust bridge. Let's just put it that way. It's a trust bridge between between your Kubernetes cluster and then your AWS IAM. So this just allows you to establish trust. It just helps you to establish trust. So what that means is that once you have OIDC connected, now what this does literally is that the AWS IAM or whatever workloads, it could not even be OID, it could not even be AWS, it could be any service. Now what that service does is that if someone wants to communicate with something at this other end, right? It goes and knock on this person's door and informs the person that my name is this. These are my credentials. I want to connect. Now, the person does not go back. Now, this other entity on the right hand side does not go back to further ask for other details. What it does is that it looks if it has someone that it trusts already, right? And then it goes ahead to ask that person that it trusts already to say that, okay, this person wants to connect. Is is the person who is the person a real person, or are you aware of this particular person's information? And then open ID Connect can now go ahead to say that yes, I trust this person because I have signed, on behalf of that person, that person is good to go. And then based on that, um, the other entity that you have on the right hand side can now allow this other person that wants to connect to, securely connect. So this is just more like a bridge of trust. Um, in such a way that anybody that wants to authenticate with a particular service, right? The end user here or the end service does not communicate with this directly. It goes to someone that I trust already, someone can someone that can vouch for the identity coming in. And then based on that, if the trust responds to say that, okay, yes, this identity is real, then the identity is now authenticated to, come in, so to say. So the OpenID Connect, which is the OIDC, whenever you hear OIDC, just know that we're talking about an authentication protocol. It acts as an identity layer on top of your framework itself. So the same thing already applies here, right? So if this service account that you can see here, if the service account needs to communicate with AWS, AWS does not go back to say that, oh, can you identify, can you tell me who you are? It doesn't go directly to the service account. Instead, it calls an OIDC that has been configured. So once you create an AKS cluster, automatically, once you create an AKS cluster, it doesn't come enabled by default. You have to sort of, enable the OIDC provider. And then once you've done that, the OIDC provider is going to be installed on your EKS cluster. And then once that has been installed, you can have like, the trust relationship that I just explained. So, yeah, so that's just that. And how do you check the OIDC, right? So you can go to your Kubernetes cluster. I'll just duplicate this. So once you duplicate this, you can just search for your EKS. All right, so go to the Champions League final, and then here you're going to see the OpenID Connect provider URL. So this is the URL that will serve as a bridge between your Kubernetes cluster as well as what the AWS IAM. So it's very simple. All right. So um again, you have to define the trust policy, right? And this is an example of the trust policy. So you have to define that within the role. And then once you are done, then you can now go ahead to now create your policy. But by the time the service account gets authenticated to AWS, what can it do? What can it not do? So that is what has been defined within this list policy. So right now we are saying that once the service account, once it gets access to AWS, this is just the only thing it can do. It can only list buckets. It can't do any other thing, right? And then you now have to provide the ARN. Because once you hear ARN, you should know we're talking about AWS resource name. And this is what uniquely define the different resources that you have within AWS. So, but right now we are saying that once the service account gets access to AWS, this is just the only thing it can do. It can only list these buckets, this S3 bucket. It's as simple as that. Okay. So, yeah. So let's go ahead and create a pod right now. So our EKS cluster is running. We have created the role. We have created the trust policy. We have also created the S3 bucket policy, right? Of what the service account can do. And right now we can only say it can list, buckets within AWS. So right now, the next thing we have to do is to create our service account. So by the time you come here, you can, I just defined a very simple manifest of a service account. So the name is S3 Reader SA, and this must correlate to what you define within your trust relationship here. So you can say that this S3 Reader SA and the name of the service account, they must be different. If sorry, they must be the same. If they're different, then you start having issues. The namespace is also default. That is why we have the default here. So whatever namespace that you define you can also affix that here. So you define the namespace, you define the service account, which is the identity that the pod is going to make use of. So once you define that, the next thing you have to do is, which is now the connecting bridge, is now to define this annotation within your service account, right? Where you now make use of the role ARN. And how can you get the role ARN? It's quite simple. You just go to your AWS, go to the role itself, and then you can grab the ARN from here. So this is the ARN for the role that we've created. Or if you don't want to come to the console, I've defined some outputs.cf here, where after creation of your EKS cluster as well as the different resources, you can now output their values, right? So you can output the cluster name, the OIDC provider, the ARN of the S3 reader, as well as other information. So you do that by just typing Terraform um, outputs. So once you type that, you have all the information that you need, the cluster endpoint, the cluster name, everything I've actually defined here. You can get that from here. So what we just need to do is to copy the ARN name, the you know the ARN for the role. You copy that and then you put that here. But first, let's not do this. Let's see what will happen by default if we don't provide the ARN within the service account. So let's go ahead to create a pod. So this is like a simple pod. The name of the pod is what? S3 reader role. And the service account would have to be the service account that we want to, that this pod needs to make use of as an identity. So for now, just going to comment this out and let's see what happens by default if we create a pod. You can see that this is just a simple pod. It doesn't have anything. This is just a simple pod. Let's see what will happen if we go ahead to just apply this pod. So okay, get node just to confirm that I am logged into my my Kubernetes cluster from the CLI. So this confirms that I'm in because indeed this is the node that the node group has assigned to me. So what we need to do is let's define what we have here and just do a k apply minus f pod.yaml. So this is going to create a pod. So once the pod is created, you can do k get pod. Just a simple workload. So you can see that this is running. So now let's exec into that pod to see what has been created. So I'll do k exec using the interactive mode. The pod name is S3 that pod, exec into it, and then I'll just initiate a bash terminal inside the pod. So right now I'm inside the pod. So let's see what happens. So let us see the environmental variables that have been created inside that pod. So right now these are just the default environmental variables that we have within the pod. So if we can let's see if we can list bucket because by now we shouldn't be able to list buckets, right? Because we commented out the service account because it's this service account that is going to, you know, help us to be able to list the buckets on AWS. So right now, let us do AWS S3 lists, S3 LS rather. So you can see what is happening. So by default, we didn't define any service account. So by default, this pod itself has inherited the role of the node. It has, inherited the role of the node by default. So now what happens is that it's telling us that we are not authorized to perform lists all my buckets because there's no identity-based policy. This is fine. We agree. But the pod has automatically, claimed it's currently using the role that has been assigned to the node itself. So let's see what this does. Let's just copy this role and see what it does by default. So ideally, the pod is supposed to make use of this reader role, but because we didn't define anything, it's default to making use of the role of the node itself. So let's see what has been configured within that role, right? So you can see that this is the role. And the role, of course, does not have any S3 list. It cannot list any S3 bucket by default, and that's why we are getting this denied error, right? So let's see what this particular role can do. So it has some policies here, and part of the policy is that it can describe VPC, it can define volumes, it can describe subnet. So let's go back to the pod and do something very interesting. Let's do AWS. So I just need to mute this. Okay, so let's do AWS EC2 because based on what this role can do, you can see that right now, the role can do a whole lot of things. It can describe subnets, it can describe volumes, it can do so many things, right? So let us assume that this is a compromised pod. This pod has been compromised, right? Because by default, it can assume the role of the node. So it is compromised. The role, the rogue user, right, is just trying to see what it can grab as fast as possible. So right now, it wants to describe VPCs. Do you see what is happening? By default, the rogue user can see all of the VPCs, all of the, um, um, the VPCs that has been created in these accounts. So if I should go back to my AWS console and then go to VPC, let's see what we have there. So this is the VPC and see the different VPCs that we have. The virtual private cloud, you can see that we have what? Two VPCs. So automatically, the rogue user can see everything about my VPC. So you can see that by default, even if you don't do anything, by default, this is just a simple pod. Even if you don't do anything and your pod gets compromised, by default, the user will be able to, view basic details. And that is where IRSA comes into play. So right now, by the time we configure IRSA would ensure that this pod should be able to do only what it has been authorized to do, right? So I'm just going to exit from here. I'm just going to exit from here and then do my get pod as well. So we'll just go ahead to delete it. But before that, let me clear the screen. Let me clear the screen and do get pod again. So you can see we're just keeping things simple, but as simple as things are, if care is not taken, anybody that gets access to your environment can quickly take over your AWS environment if you don't do all of these golden parts that we're talking about. So let's go ahead and delete this pod. So let's go ahead and delete this pod. So it might take some time to delete. So I'll just add grace period so that this can be forced. Grace period is equals to 0, and then I'll just force it to delete. Yeah, so this has been deleted, right? So let's now go ahead to now do the right thing that we need to do. So let's configure the service account, but before that, we need to get what? The ARN for that role. That's for the role that we want the service account to be able to, assume. So I can just do my Terraform output again. Output. And by the way, this is going to be published on YouTube. So all of these credentials that are here would they wouldn't work after now because I'm going to do a Terraform destroy to destroy all of the resources. So right now we'll copy the ARN. This is the ARN that we have here. I'll just copy the ARN. I'll put the ARN here. This is going to save automatically. Then I'll go to my pod and then I will re-enable the service account so that the identity so that this pod is going to make use of this identity so that when this pod wants to go to AWS, it goes to AWS, knocks on AWS door and say that my name is S3 Reader SA and I want to list buckets. So AWS checks to see to see that it has a trust policy already via the OIDC, and then it sees that okay, yes, you are good to go. AWS will now give it access to, list the buckets based on the policy that we have defined. All right. So let's go ahead and do apply and apply the pod this time around. And then we'll go ahead. I'll just what is it saying? Okay, sorry. We have to create so you can see that if the service account does not exist, it's going to complain that it that it cannot find the service account. So we have to create the service account first. So this service account will have to be created first. So k apply -f sa.yaml. So service account has been created. Then we can now go ahead to apply the pod. So once we apply the pod now, the pod has been created. Then we can exec into the pod once again and see what we have. So once you exec into the pod and do your env, you can see that right now, based on this annotation that we did, right, we have more environmental variables that we have to play with. But the two important ones that you have to take note of right now is that you have to take note of the AWS role ARN, as well as the AWS Web Identity Token. So I won't go much into what this does, but ideally, what this does is that this has a token, right? This has a token, and then when this pod wants to communicate to AWS, it makes use of this token as well as this ARN. It presents both this ARN and this token. It presents it to AWS, and then AWS, now calls the OIDC. Remember, the OIDC is what serves as a trust bridge between the EKS cluster as well as the AWS um, environment. So it calls the OIDC to, just validate if this guy is who he say he is, right? So it makes use of this token. It presents a token. It also presents the ARN, and they make use of this, the combination of this and this to log in. All right. So right now, let's now see if we can, you know, if we can list buckets, because of course within the policy here, this is the policy that I've defined. If we just go back here, you can see that this is the policy that we've defined. And then we say that within the policy, it should only be able to what? List buckets. And what kind of bucket should it list? You'll be able to list this bucket. So if we go back here and do AWS S3 LS, you can see it's going to tell us that right now we are not authorized to list all buckets, because this AWS S3 LS is going to list all of the buckets. But right now, what I've said it should do is just to list a specific bucket, and that is why we are getting a permission denied. Now, this now shows that we are not making use of the default role on that node, but right now, what we are making use of is what we are making use of the IRSA S3 reader role. So if we now go ahead and do AWS. So just do this same command, but instead we'll now point to our S3 buckets. I believe this is how they point to the bucket name. So we'll just go ahead and then point to these buckets. Let's see. We'll just point to these buckets. And by the way, this is the buckets that's is trying to point to. And inside this bucket, we just have like the event for this, the event picture, for this particular demo. So go back there and just put it there, and let's see. So we can see that right now you are now able to what list the objects in that bucket. So this is how you do IRSA, by giving your pod what it should have access to. So you are doing, least privilege. You are not just giving this pod a wide open privilege to just do things, right? So as simple as this sounds, there are so many organizations that don't follow this principle. And then when there are incidents, and then when you are checking through all of those incidents, you now realize that IRSA was not properly done. All right. So that just brings us to the end of this show and tell. Just like I've said, this should be 30 minutes, but I don't know how this got to 1 hour. I'm sorry. So yeah. Um, so I'm just gonna exit out from the pod, and I'm going to be taking down the resources. So I would first delete. Okay, so before I delete, we'll just take a question. Does anybody have any question?